Hello guys, we are back with our next tutorial. In this tutorial, let us go through deadlocks. So basically, we have already discussed how deadlocks are formed and what are the reasons for deadlocks, as we have discussed about the kind of concurrency control things. We have just gone through the basics of deadlocks, guys. So in this tutorial, we'll be starting deadlocks and how we can detect deadlocks. We will be learning in this lecture, guys. So basically, what is deadlock? So when a particular transaction is having a particular resource and is requesting for a particular resource, and that particular resource is with another transaction, and that transaction is requesting for this resource. So here, if you observe, you formed a cycle with these requests which will never fulfill unless and until one transaction complements or cooperates with the other. So this situation will be calling it as deadlock. Fine. Okay. A system is in deadlock state if there exists a set of transactions such that every transaction in the set is waiting for another transaction in the set. Okay. So if you observe Ti and T2, T2 is requesting for lock on X. Lock is nothing but is requesting for that particular resource, and T1 is requesting for the lock on Y. So that particular resource it is waiting. So they are in need and they are having this. So I hope everyone got a small idea on deadlocks. So now let us go through how we can detect these deadlocks. Okay, so basically detecting deadlocks is really interesting and easy, guys. It is really easy to understand. If you understand the main concept, how we are doing it, it's easy, guys. Okay, so deadlock detection. Simple way to detect the state of deadlock, it is to be drawn a wait for graph. So basically we will be drawing a graph which is having G as graph G with V and E. V is nothing but the non described transitions and E will be the directed edges. So transactions are nothing but V and E will be your edges. So basically when we write E, Ti tends to Tj. This situation is nothing but a directed edge. When we draw is nothing but Ti is waiting for the resource data item held by Tj. Tj is having an item that is requested by T1. Ti, okay? So Ti will be requesting Tj. So in this way we'll be representing. Fine? Okay. So once we are going through the example, you will be having a clear idea, guys. Don't worry. Fine? Okay. So before doing this problem, you should have some familiar idea about shared lock and exclusive lock. Shared lock means, shared lock means it will only have the read option, whereas executive or exclusive lock means it will be having read and write. Fine. So here if you ask which is powerful, means we can say, once we are going through the problem, I'll be analyzing, guys, because if I confuse you again, you'll be confused. Fine. Okay. So now let us start the problem. Okay. So initially the transitions and data items and lock modes are given. So Ti needs TQ. So it is trying to request for a shared lock. So initially there are anything, guys, it's an empty, right? So that is the reason why there is no problem. So Ti will be requesting for Q. So requesting will not be given here. Only the request for a particular transition will be given. So T2 is requesting for P, right? So it is asking for exclusive. So fine. Even T2 is given for P. Now T2 is requesting for Q, that is also exclusive. So I told you previously, we can convert exclusive to shared and shared to exclusive, right? I hope everyone remembers that. But here basically we can combine the same types, but any other different types like shared and shared we can combine, but any other combinations we cannot combine. Please remember that. So T2 is requesting for Q, that is exclusive. So T1 is already having Q, so it is requesting, T2 is requesting Q1, T1. So in that way you need to draw the diagram, or you can keep a normal arrow also, it's fine, but for clarity I have just kept a long arrow. Fine. So after that T3 is requesting for Q, that is shared. I told you shared and shared are the only friends, so there could be no issue. The lock will be acquired, and at the end T4 is requesting for P and it is exclusive. So already exclusive is given for P. I told you only shared and shared are friends. So T4 will be requesting to T2, right? So as it is having P, so write T4 is requesting to T2 and T3 will be empty, so it will not be having any transactions. So this will be your graph diagram or representation to find whether deadlock exists. So now I have just written a small theory. Now check. So now T2 needs the lock Q, but it is already with T1. So T2 requests for T1, that is nothing but T2 tends to T1, as lock types are different. So that's what you should remember. Similarly, T4 wants to lock a Q, which is already locked by T2. Hence, T4 is requesting for T2. So now here we didn't see any cycles. Then we can say that there is no deadlock. Fine. So we use two methods, guys. Those are nothing but, in deadlocks we'll be using two things. Those are nothing but deadlock prevention and deadlock detection and recovery. Guys, we have just now discussed about detection. So in the next tutorial we'll be going through prevention, and after that we'll be going through recovery. So let us meet in the next tutorial and we'll be discussing about deadlock prevention. Thank you. Thanks for watching.